In this lecture, we'll introduce the basic concept of inheritance in C# using both our coin and our apple pickups as examples. At the moment, in our prefabs folder, we have both our apple and our coin both using this same pickup script. But how can we go about separating the logic to make sure our apple does something different than our coin? Now, I'm sure we could do something relatively messy in our pickup class. Somewhere in here, we could do a whole bunch of nested if statements and say, hey, if this is the apple, then do this, and then if this is the coin, do this. But you can imagine that would get really messy really fast if we had more than just a couple different pickups. So to keep our code modular and readable, I think it's time we talk about inheritance. So what is inheritance? Inheritance is a concept inside of object-oriented programming, or OOP for short, languages like C# that allow a class to inherit properties and methods from another class, commonly referred to as a base or a parent class. For example, at the moment we have a single pickup class for both our apple and our coin. Well, we can actually separate our coin and our apple into two separate scripts, both inheriting from our pickup class. That way both our coin and our apple classes can inherit all of the different members inside of pickup. When I say members, I mean things like variables, properties, methods, and so on. And this can go deeper than just one level. For example, you could actually inherit from apple and it would also in turn inherit from pickup. Now, we're not actually going to have a great use case in this project. It's a bit out of scope. But for example, you could have something like a green and a red apple. Maybe the green apple poisons you for whatever reason, and the red apple actually gives you some sort of different power-up. This hypothetical green and red apple would inherit everything from apple as well as everything from pickup and so on. But when should we actually use inheritance? Inheritance is an extremely powerful tool that we can put inside our tool belt, but it's not always the best choice. There's a common phrase in object-oriented programming to favor composition over inheritance. Most of the time, we should favor composition, things like combining simpler objects to build more complex ones. There are some helpful tips that we can use when you're trying to make those types of decisions. Inheritance has a is-a relationship. For example, a dog is an animal. A cat is an animal. You could actually have a dog and a cat class inheriting from a base animal class. However, you wouldn't use inheritance for something like an engine or a wheel inside of a car. You wouldn't say something like a wheel is a car or an engine is a car, but a car has an engine and a car has a wheel. Those are the types of times when you would favor composition over inheritance. In our case, however, we both have an apple and a coin, and both an apple and a coin are both pickups. In other words, they have a is-a relationship. Since both a coin is a pickup and an apple is a pickup, let's go implement a nice example using inheritance for both our coin and our apple. Inside of our pickups folder, let's create two different classes for both a coin and a pickup. So create a mono behavior script, and I'll create a coin script, and we'll go ahead and let that compile. While we're here, let's also create an apple script. So another mono behavior script, and we'll just call this one apple. Let's open both of these up in VS Code. I'm actually just going to go ahead and drag our apple over to our right and keep our pickup over to our left, collapsing our player handler class. We don't need that at the moment. Let's also open up our coin class, and we can keep that on the right as well. You can see here in our pickup class, we're inheriting from mono behavior. Mono behavior does a lot of things under the hood. This is actually what's allowing us to attach things to game objects, for example, or give us the Unity lifecycle, giving us methods like awake, start, and update, for example. Well, in our coin and our apple, we don't actually want to inherit just from mono behavior. We want to inherit from pickup. So you can actually just delete mono behavior entirely and replace it with pickup. But because our coin is inheriting from pickup and pickup is inheriting from mono behavior, our coin will still have all of those built-in Unity methods, things like awake and start, because it still is inheriting from mono behavior. Let's go ahead and do the same in our apple. Let's just make sure that we're also inheriting from our pickup class. Before we go any further, let's actually just see what that looks like back in Unity. Back in our prefabs folder, let's actually on our apple and our coin just delete this pickup class component entirely. On our coin, let's actually just attach our coin class. You guessed it, let's just add our apple class as a component on our apple. Everything should be working the same. When we run over a coin, great, we just hit player. And when we're running over apple, we still actually are logging player in our console. Everything is actually still working as intended, even though we don't have this pickup class directly attached to the apple or the coin. Well, let's go one step further and actually drive this point home. Let's actually get all of our coins and our apples rotating on what I believe is our y-axis. So for example, if I just click this coin here, go into my coin pickup, I want them to actually just all rotate on the y-axis. In other words, it'll just kind of be rotating around our game on the y-axis on each individual pickup. So let's go ahead and unpause our game here and open back up our pickup class. With our pickup class open, we just need to create some sort of serialized field for a rotation speed float. So I'll go ahead and create that float as a serialized field, and I'll just call that rotation speed. Let's initialize that to 100F for now. Inside of update, let's get each individual pickup rotating. So let's create a void update method. And inside here, we just need to get everything rotating. We can do that by calling transform.rotate with a capital R, and then just passing through whatever sort of values that we want to modify. So 0 on the F, we only want to rotate the Y. In our Y, we want to use rotation speed times time.delta time, just to make sure everything is frame rate independent. And on our Z value, well, we don't want it to rotate at all, so we can also just keep that as 0. And even though we haven't actually typed any code in both our apple and our coin, they're both inheriting from our pickup class, so we should have both our coins and our apples rotating, even though they actually don't have the pickup class directly attached to it. However, we need to actually finish off one more step. You can see that both in our coin and our apple class, we haven't actually deleted this update method. So this update here inside of our apple that is being derived from our pickup class will actually override this update method here. And because inside of this update method, there's no actual simple logic, we won't actually have our pickups rotating yet. So we need to actually delete the update method in both our apple and our coin. While we're here, let's just actually delete start as well. So in both our apple, delete everything there, and our coin, delete everything here. Let's go try that out back in Unity. All right, let's go ahead and try that out. Let's hit play. And there you go. We have all of our coins and our apples rotating, even though in both of those separate classes, both our coin and our apple, they don't actually have any sort of logic inside of them. It's just inheriting from our pickup class. I think the next logical step is introducing some sort of separate logic in both our apple and our coin class, even though they're both inheriting from pickup. For example, when we pick up an apple, we want to give our player some sort of power up. When we pick up a coin, maybe we just want to increase our score. To do that, we need to actually introduce a few more keywords inside of C# that we can use. Now, there's a lot of different keywords that we could actually talk about, but there's 3 main keywords that I'd like to focus on at the moment. The first new keyword I'd like to introduce is the word protected. It's the same sort of keyword when introducing a method, for example, things like private or public. Protected is only accessible within its own class and derived classes. When using the private keyword, you can only call methods within inside that class itself. When using the public keyword, we can actually call that method from other classes as we've become familiarized to. Well, the protected keyword is only accessible within its own class and derived classes. The next keyword we'll use is override. It replaces the base class's implementation of a method or a property. For example, you might actually have some sort of generic onPickup method inside of your pickup class. If it's not overridden by anything that inherits from it, it'll go ahead and just implement that sort of basic logic unless something overrides it in a class that inherits from it. The last keyword that I'd like to talk about is the keyword abstract. It declares a class or a member that must be implemented in a derived class. However, it can't be instantiated on its own. I know some of this can sound overwhelming at first, but like everything else in Unity and C#, once you actually start to become acclimated with some of these keywords, I think we can start to demystify what they mean pretty quickly. Let's hop back into our Unity project and see if we can implement some basic use cases for these keywords. Let's start out by opening back up our pickup class. In our pickup class, let's actually introduce our first protected abstract method. Let's create a protected abstract method, and we don't need to return anything, meaning we can actually just go ahead and use the keyword void, and let's call this onPickup. This protected keyword here means we actually won't be able to call it from other classes unless we actually inherit from it, for example, like our coin and our apple. The abstract keyword means we actually have to implement it in some of these other classes, like our coin and our apple, or we'll actually get an error. We'll go ahead and take a look at that in a second. However, we're still actually getting one more error here on pickup because we actually need to use the abstract keyword for the entire pickup class. So here at the very tippy top of our class, we actually want to change this entire class to an abstract class. So we actually do that by just typing public abstract class pickup. That will get rid of our compilation error down below, but it will actually also make this class impossible to instantiate it on its own, meaning that you actually cannot now attach this pickup class directly to a game object, for example, and instantiate it into our scene. You have to instantiate either a coin or an apple directly and inherit from our pickup class. You can no longer use this pickup class directly and attach it to a game object as a component, for example. And if you take a gander over here to the right side of our screen, it does actually introduce some new compilation errors. So if we scroll over our coin here, we can actually see that our coin does not implement inherited abstract member pickup on pickup. Well, that's really just a fancy way of saying we don't have an onPickup method in our coin pickup class. This abstract keyword over here on the left is basically saying anything that inherits from pickup has to have its own onPickup method. So let's actually do that. But to give us a little bit more space, let's actually just collapse these back all into one window. We now over here have to create a protected override function. This override keyword is going to override the onPickup method over in our pickup class. So protected override void, and we just have to create an onPickup method. And I think if you autocomplete it, yeah, there you go. It'll actually throw a new system not implemented exception, just so that way we don't get any sort of error. But this is really basically just a fancy way of saying don't throw any sort of error, even if it's not implementing any sort of logic. Well, for now, let's actually just debug.log. And this is our coin. So let's just say something like add 100 points. That way, when we pick up a coin, it'll print to our console, add to 100 points, but only for our coin and not our apple. Well, let's go print something else to our console in our apple class. But there is a bit of a shortcut. You could actually just highlight apple here, click the little light bulb, and then just click implement abstract class, and it will auto-populate the methods that we're missing to get rid of that compilation error. Well, in here, we want to do the exact same thing. Let's just debug.log a different message. So in our pickup, let's actually just say power up. That way we now have everything we need so that our apple and our coin should be printing two different messages to our console depending on which one we pick up. The last thing we need to do is actually just call this onPickup method in our pickup class. So instead of actually printing the other.gameObject.name inside of our onTrigger method, let's actually just replace that entirely with onPickup, which is actually calling this onPickup method inherited by both our coin and our apple. I think it would also make sense that after we call onPickup, we also just destroy the game object that we pick up. Nice, let's go try that out back in Unity. I think we should have everything set up correctly. Let's just go ahead and hit play and take a look at our console. When we pick up a coin, we get added 100 points. And when we pick up an apple, we actually get the power up debug.log printed to our console. And of course, we're destroying whatever object that we run over as we pick it up. Let's navigate back to our prefabs folder. And I just want to show you that on your apple and on your coin, even though we actually don't have an exposed serialized field on both the apple and the coin classes, you can still see the rotation speed exposed float serialized field that we actually have in our pickup class on both the apple and the coin because we're inheriting from the pickup class. I think the last thing I'd like to do before I move on is just ever so slightly increase the size of my king. Now, this is a bit optional and it's somewhat of a preferred preference, but I think I would like my player model to actually just take a little bit more space on the bridge. Probably something like a 20% increase size on my entire player. So I'm actually just going to go ahead and increase the size of my king to something like, I think around 1.2 makes sense. So I'm actually just going to lock the X, Y, and Z value and just change that to an equal 1.2. Just on my entire player game object to make sure my capsule collider is also scaling with it as well. I think we're also going to need to just also slightly shift up my entire player model, just so once again it looks like I'm running on the ground. Yep, there you go. That was actually a pretty good guess. I think that's accomplishing a bit more accurate proportions for what I'm looking for inside of our game. Great, well done on this lecture. That was a lot of new material to digest. Even though that was a relatively basic use case of inheritance, I hope that you can immediately see the power of it. Give yourself a pat on the back, and when you're ready to move on, I'll see you on the next lecture.